Alrighty, Ms. Whitaker here again, and we're going to continue our discussion on fractions. We want to get into adding and subtracting fractions, and before I do that, I want to talk about equivalent fractions. And equivalent fractions are fractions that have the same value. So I'm just going to throw out 1/2, because 1/2 is easy to see. And if I asked you, give me some equivalent fractions to 1/2, give me some other fractions that also mean 1/2. And you could throw out, oh goodness, you could do 3/6, you could do 4/8, you could do 12/24, you could do 40/80, you could do 500,000. There's a whole bunch of different ways you could say 1/2. But if you look at it, well, these are really big numbers. But did you know that these numbers, even though they're much bigger than 1 and 2, did you know that 500,000 is the same amount as 1/2? That 12/24 is the same amount as 1/2. That 40/80 is the same amount as 1/2. And if I were to draw that on a number line from 0 to 1, and I marked my 1/2, that also 40/80 would be right there. That 500,000 would be right there. Did you know that? These are all equivalent fractions, and what that means is they have the same value. So make sure you understand equivalent fractions, because that's what we're going to talk about as we're talking about adding and subtracting fractions. We cannot, also just to throw this out there, we cannot add fractions that have different denominators. It's like apples and oranges. If I have, let's say I have 4/5, and I want to take away 3/4. My goodness, I have 4/5 and 3/4. Those are totally different fractions, totally different denominators. So I'm going to picture 4/5, 1, 2, 3, 4, 1, 2, 3, 4/5, and I'm going to picture 3/4. That's 3/4. I cannot, they just don't match up. So I'm going to have to make them all the same denominator. It's like apples and oranges. I can't take oranges away from apples. I can't take apples away from oranges. I can't add apples and oranges. And then I'd get something like, what, Angie's or Orples or something like that. Can't do that. So I either need to change them both to apples or change them both to oranges, or sometimes I might need to change them both to bananas, to something completely different. So now that we know a little bit about equivalent fractions and that they have the same value on that number line, I want to do some modeling for you. So I'm going to write down the fraction 1/2, and I'm going to model that for you on here. 1/2 would be represented. There's 2 halves, that makes a whole, and then 1/2 would be one of these shaded. So hopefully you understand that this models 1/2. All right, I'm going to write down another fraction, 3/4, right underneath it. I'm going to start at the same line so I can kind of understand what I'm talking about here. And I'm going to break that into fourths using these grid lines. And then I'm going to shade in 3 to represent 3/4. Now, the problem is, if I want to add these two fractions, I'm not lining up here. They need to line up. I need the same denominator. So what I'm going to do is I'm going to see if I can make these end at the same line. Hopefully I can. Now, I don't need to move this out unless I need to after I've moved this one. So I'm going to have to start with the smaller one to see if it can catch up to the larger one. If it goes past it, then I would have to extend both of them. But we'll just see what happens. So I'm going to take this 1/2 and I'm going to do it again. And I'm going to do 1/2 again right here, and I'm going to shade one of the halves. So now I have 2 out of 1, 2, 3, 4. Now I have 2/4, and I actually did line up just where I needed to line up. So if I were to add these now, this fraction and this fraction, so 2/4 plus 3/4, how many are shaded? 1, 2, 3, 4, 5. So that equals 5/4. Just remember again, we cannot add apples and oranges. We're going to have to make them the same denominator. Now, taking going a little bit farther from these models, I'm just going to extend some fractions using equivalent fractions. So let us list some different equivalent fractions for 1/2. So we've already talked about we just threw out some before, but let's go in order. If I multiplied the top and the bottom by 2, what would I get? 2/4. All right, what if I multiplied, let's just stay with this 1/2. If I multiplied them by 3, both the top and the bottom, what would I get? 3/6. That's still 1/2, 1/2. If I multiplied them by 4, I would get 4/8, still 1/2. Then I would get 5/10. I would get 6/12, 7/14. So I could just keep going, but I'm just going to stop to see if I've gone far enough. All right, then I'm going to add 3/4 here, and I'll just do some equivalent fractions here. Let's do 6/8. Then we're going to multiply by 3 and get 9/12. Multiply by 4 and get 12/16. And all I'm doing when I'm adding these two now is figuring out which fractions have the same denominator. And I really want to stick to the lowest one. So already I see I had one from the very beginning, 3/4 and 2/4. The denominator's the same. So now I can combine those because it's talking about how many fourths I have. I have 2 here and I have 3 here. If I'm going to combine them, then I'm going to have 5/4 altogether. All right, so here's my answer, 5/4. If I change that to a mixed number, I'm going to see how many times 4 goes into 5, one time with 1 left over, but I'm still dealing with fourths. I'm going to draw you a picture of what that looks like too. Okay, we're dealing with fourths, so I'm going to separate my whole into fourths, and well, I need 5 of them. So I'm going to 1, 2, 3, 4. Ran out, so I'm going to have to do another whole here, and then do the 5. So 1 and 1/4. That's what that means. All right, so now that that's clear, let's do another problem. I'm going to do 2/3. 2/3 plus 3/4. Now let's extend the equivalent fractions, and we're just going to stay with the initial fractions, and we're just going to extend it out. So let's list some equivalent fractions to 2/3. If I multiply top and bottom by 2, I get 4/6. If I multiply the top and bottom by 3, I'm going to get 6/9. If I multiply the top and bottom by 4, I'm going to get 8/12. If I multiply them by 5, I'm going to get 10/15. And by 6, I'm going to get 12/18. You notice I'm putting all these equal signs because they all equal the same amount, so don't forget that. All right, I'm going to stop there and see if I've gone far enough. So I'm going to do it for 3/4 as well. We are adding here. Don't lose that. All right, if I multiply top and bottom by 2, I'm going to get 6/8. If I multiply them by 3, I'm going to get 9/12. If I multiply by 4, I'm going to get 12/16. If I multiply by 5, I'm going to get 15/20. But you know what? I've already noticed that I'm matched up a denominator right here. So I'm going to add these, 8/12 and 9/12, and that totals 17/12. Change it to a mixed number. This is improper, and that's okay. I have 17/12, but if I want to change that to a mixed number, I see how many times will 12 go into 17. Goes one time with 5 left over, but I'm still dealing with 12. Let me show you a picture of that. All right, I'm going to have to draw 12s here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Tell you what, I'm going to go this way a couple. And then separate that into 12s. And I need 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I need more. So I'm going to draw another set of 12s. So I had 12 12s, that's one whole. So I need 13, 14, 15, 16, 17. So here's a representation of 1 and 5/12. I have one whole and then 5/12 remaining. So 1 and 5/12, that's why 17/12 is the same thing as 1 and 5/12, because 12/12 is one whole, and then we had 5/12 still to color in. So what I want you to do when you're adding now is use equivalent fractions. Let's try this method just so you know that when we're adding or subtracting fractions, we've got to have the same denominator. We've got to have apples to apples, not apples to oranges. So I want to make sure that you're understanding that 2/3 is the same as 8/12, that 3/4 is the same as 9/12. And if we're going to add these together, we've got to make it a denomination that we have in common. Sometimes when we just get the common denominator, we forget to change the numerator, because we got to make sure that we know that 3/4 is not the same thing as 3/12. So we change the numerator. So if you list out your equivalent fractions, I think you're more prone to understand that it's a completely different numbers, both on the top and the bottom. And then we're going to combine those when the denominators are the same. But go with equivalent fractions. Try that before you add or subtract, and let's see how we do. So email me if you have any questions. You got your homework. You're going to do those problems and use those boxes, fill in all the boxes, and we'll do some problem solving next time we meet.